Hi and good day everyone. Welcome to Hosey How to channel. Today I would like to share with you how to create system characteristic curve for multi-tanks pumping. I have received many requests to determine the multi-tanks pumping after releasing my earlier video for how to create the system characteristic. This video is an extension to my earlier video. If you want to learn more about the basic of creating the system characteristic curve, you can click the link at the right upper corner for more details. For a multiple tanks pumping, it is a complex pumping system involving more than one receiving tank. As I stated before in my earlier video, the calculations is normally done by using a commercial engineering software. However, to explain the basis of this pumping system, this video will illustrate a simplified pumping system where a pump is pumping concurrently delivering water to two receiving tanks with different flow and level. Let's look at the schematic diagram of the pumping system. Here, the two receiving tanks are located at different level and receiving different flow. A sump at the lower level will be pumped to these two higher level tanks through a common piping and branched at a junction located at an elevation of 15 meters. The details such as distance, water level, flow demands, and pipe diameter are shown in the schematic. To determine the system characteristic curve for this pumping system, the following steps should be followed. Step 1. Develop the pipeline resistance curves for path 1 taking into account the static head component from the junction to tank 1. Step 2. Develop the pipeline resistance curve for path 2, once again taking into account the static head component from the junction to tank 2. Step 3. Combine the two parallel paths, that is path 1 and 2 by taking a head value and summing the flow rates from the resistance curve to arrive at a combined flow rate for the parallel paths. Step 4. Develop the pipeline resistance curve for the common pipe, taking into account the static head from the sump to the elevation of the junction. Step 5. Combine the curve from steps 3 and 4 above in series to develop a system characteristic curve. Finally, step 6. Superimpose the system curve with the pump curve to develop a pump performance and system characteristic curve. I will walk you through how this can be done. Step 1. Develop the pipeline resistance curves for path 1. To develop the system characteristic curve for path 1, I will use the spreadsheet which I have shared in my previous video. This will make the calculations much easier. Let's input data for path 1. Press the calculate button. Then, go to the multi-tank curve sheet, click the path 1 button to fill the path 1 column. The system characteristic curve for path 1 is created on the graph sheet as shown below. Step 2. Develop the pipeline resistance curves for path 2. With the similar input, enter the flow, pipe length, fittings and water level for path 2. Similarly, press the calculate button. Then, go to the multi-tank curve sheet, click the path 2 button to fill the path 2 column. The system characteristic curve for path 2 will be plotted on the same graph. Step 3. Combine the two parallel paths. For this step, we need to use the same pressure head to determine the flow for each path. To do this, we need to apply the add trendline function in Excel and display the curve formula for the higher head curve. Next, compare the head for path 1 and path 2. In our case, the head for path 1 is higher than path 2. We will fill the adjusted path 1, which has the higher head by choosing the row for path 2 where the head is higher than path 1 minimum head. From the minimum head of path 1, this is 25 meters, we will adjust the path 1 curve starting from this head. Copy the curve formula and paste them to adjusted path 1 and replace the X with the flow cell. Then, fill the remaining row with the formula. Adjust the flow to match the head of path 2 at the same row. This can be done by trial and error by adjusting the flow at the adjusted path 1 column. Similarly, do the same for the remaining row. Then, combine the parallel curve flow by adding the adjusted path 1 and path 2 flow using the same head. This will be done automatically. The combined path 1 and 2 curve is then plot on the graph. Step 4. Develop the pipeline resistance curve for the common pipe. For the common pipe, enter the flow, pipe length, fittings and water level at sump and junction as below. Total flow equals 175 liter per second. Note that this is the total flow for both demand for tank 1 and 2. Press the Calculate button. Then, go to the multi-tank curve sheet, click the Common Pipe button to fill the Common Pipe column. The Common Pipe curve will be plotted on the graph. Step 5. Combine the curve from steps 3 and 4 in series to develop a system characteristic curve. To adjust the Common Pipe flow and corresponding head, we will need to again use the trendline in order to obtain the formula. Once the adjusted common pipe head is determined, the spreadsheet will calculate the total head automatically by combining the head of the adjusted common pipe and the combine path 1 and 2. The total head system characteristic curve will be plotted. Step 6. Superimpose the system curve with the pump curve. Next is to plot the pump performance curve. In our example, the flow for path 1 is 100 liter per second and for path 2 is 75 liter per second. The total flow for the pump is 175 liter per second. Then, insert the pump head into the pump input data section following the flow data. You can get the pump performance data from any of the pump manufacturer. Next, in the multi-tanks curve sheet, press the pump curve button. The pump performance curve will be automatically plotted. The curves sheet can be cleaned up by only providing the total head system characteristic curve and the pump curve only. From the graphs plotted, you can find out whether the selected pump is suitable or not. In our case, the intersection point shows that the pump selected has a flow slightly less than the required flow of 175 liter per second. Hence, probably a higher head pump is required to meet this flow by repeating the same step 6 above. With the higher head, the graphs show that the 175 liter per second can be met. Thanks for viewing. Please subscribe and like my channel if this video is helping. Hope to see you in my next video.